Hello students, and welcome to the final video of this lesson. In this video, we're going to be using our calculators, and I'm going to show you how you can actually use your calculator to find the values of derivatives. And then we're going to utilize it in some very AP style free response questions. Let's get started. All right, so as we're going through these problems, we're going to be wanting to find the f prime value. So we're giving functions, and we want the value for f prime at some value of a, okay? So in our first problem, we have a equal to -2. And we've got some really gnarly things, right? Because we can find the derivative of 3 to the ex sine of x. We can find the derivative with the product rule. But actually finding the exact value of the derivative at a point, that's when you get into really tricky stuff. So we're going to want to get some of these decimals here, okay? So in our first problem, we've got our graph here, and we've got our calculator here, and we're going to want to find the graph here. So you can go to the scratch pad and do graph if you're comfortable with that. I like to just make a completely new document and go from there. And so one of the first things that you're going to want to check anytime there's trig involved, especially, is that your calculator right there is in radian mode. Okay, so let's type in our function. We've got 3 times e to the x times sine of x. All right, there we go. And so we're in radian mode, so we're good to go. And what I want to do is I want to find the derivative f prime of a at -2. Okay, so what I'm going to do here is you're going to go to menu, and you're going to go to analyze graph. Okay, so this is where you're able to find zeros and maximums and minimums and intersection between two lines. Okay, very useful things in analyze graph. But you see there number 5, dy dx, that means the derivative, and we're going to want to find the derivative at a point. So I want to find, in this first problem, I want to find it at -2. So literally you just type in -2 and you hit enter, and it gives it to you. But there is something that I do want to change here, is because it gives us -0.538. And something that's very useful in the calculus test is, yes, they only check up to 3 decimal places, but I always have my students go up to 4 decimal places, just in case there's a small error. If you go up to 4 decimal places, you won't get any question incorrect. All right, so what I want to do is I want to change our options here. We're going to go to settings. And so where it says float 3, I'm going to change that to float 4. Basically, it's going to give me an extra decimal place, and if I went to 5 and 6 and 7, it will give me even more decimal places. So that's going to say -0.5381. That's the derivative, right? So we're going to write that down. F prime of -2 is equal to -0.5381. All right, and what do we want to say? We want to say, like, what's happening to our function f. All right, so we know that f of x is decreasing because f prime of -2 is less than 0. It's negative. So f of x is decreasing. Let's just put in here that at x equals -2. Because I do want to be a little bit more specific. It's not just f is always decreasing, it's decreasing at that specific point. All right, there we go. So now we're going to move on to our next problem. 3 times e to the x sine of x. So we've got the same thing. And so what I'm going to want to do now is going to pull up my calculator again. This time I'm not going to put in a new function. You could, but since it's the exact same function, all I'm going to do is going to go back to menu. I'm going to go dy dx again, analyze the graph, and this time we want to find it at 1. So I'm going to just type in 1, and I'm going to hit enter. Notice again, it only gives me 11.27. I want you to go to 4 decimal places, so we need to change the float value. All right, so I'm going to go menu, settings. If I want 2 more, then I'm going to go down to float 6. 11.2681. You saw that it also extended the other one that we got at -2. That's totally fine, but that's just extra stuff. So 11.2681. So we can write that down, that f prime of 1 is equal to positive 11.2681. And so what can we say? Well, since it's positive, f of x is increasing at x equals 1 because f prime of 1 is greater than 0. It's positive. All right, so now we're going to be looking at a different function. Again, we want to be saying what's happening. Is it increasing, decreasing, or whatever, okay? So we want to make a new one. So I'm going to go to the home screen and I'm going to make a new graph, okay? So it makes a new page here. And now I can just go to add in a new graph. And so we're going to go natural log. So control e to the x, and then it's going to give us natural log. And I've got cosine of x. So trig cosine of x. There we go. Go out of those parentheses. And we're going to divide all of that, or you could do like a control divide if you want. It doesn't really matter. And get x squared. Right, there we go. That's our function. And so where do we want to find this first one at? So we want to find this at pi over 3. What's happening at pi over 3? So let's go to menu, and we're going to go to analyze graph, dy dx, and we're going to literally just type in pi divided by 3, then hit enter. And we got our value, negative 0.372268. Remember, we only need to go to 4 decimal places. So if I round that, then we're going to say f prime of pi is equal to negative 0.3723. Actually, I need to grab that and move that up. So f prime of pi over 3 is equal to negative 0.3723. All right, so what can we say about f of x at a equals pi over 3? Well, since it's negative, we're going to say that f of x is decreasing at x equals pi over 3 because f prime of pi over 3 is less than 0. It's negative, okay? And I'm sure you're probably getting tired of writing these things over and over and over again, but it is what it is. This is the way to answer and speak in calculus, all right? So we've got another one where we're going to want to find this at pi. So I can just pull up my graph again, and we're going to go to menu. You're going to go analyze graph, and we're going to go dy dx, and you're going to find this one at pi. So you just type in pi, and then you hit enter. And it says derivative not available at specified location because it's undefined, okay? And if you're looking at this graph, around 1, 2, 3.14, the graph it's not drawn there. You see like this gap right here, there's a gap right there, right? And it's even over there on the other side. There's another gap at like negative pi. So the graph is not drawn there, it's undefined, so this does not exist. So f prime of pi does not exist. So what can we say here? Well, we're able to say that f of x has a vertical tangent at x equal to pi. And we know this because f prime of pi does not exist. So that's why we know that there's a vertical tangent there, right? And what's actually happening, if you want to be a little bit more accurate, a little bit more specific, is that you can't take the natural log of negative values. Whenever cosine is flipping into the negative values, that's when weird things are happening, okay? So that's why we've got options for vertical tangency there. Okay, we've got 2 more practice problems here. And so let's see what happens. We gotta make a new graph here. So again, I'm gonna add a graph, and I don't care that it makes a new page. We can delete all that later. And my function is e to the tangent of 0.34x. Okay, yep, I'm in radian mode, so let's go with that there. And we're going to find this at 0. So what is f prime of 0? So again, that's menu, analyze graph, dy dx, and you just type in 0. And this doesn't have additional values, right? Because we're already on float 6. So it's exactly 0.34. If there are no additional values after that, you just keep it, okay? So we know that f prime of 0 is equal to 0.34. And since this is positive, we know that f of x is increasing at x equal to 0 because f prime of 0 is greater than 0. There's a lot of zeros there, but realize like we're talking about different things, about x values, y values, and whether it's above or below the x-axis, okay? And then we've got, of course, one problem remaining. Number 6 is a different function, and we're gonna wanna find it at 1, all right? So let's do that, where again, we're gonna make a new graph. And again, like I said, you can do this all in Scratchpad. I just don't like to really reset it all. All right, and so we've got 5 times the sine, so trig sine. So when it says sine squared of natural log x, we're gonna just go natural log x and then we're gonna square all of sine. So it's gonna look like this, control natural log x. And so after the second set of parentheses, then we're gonna put in that square. So that's the only way to really do it on a calculator. And let's see what that looks like. Okay, fantastic. And we wanna find this at 1. So menu, analyze graph, dy dx, and type in 1, enter, and it comes out to be exactly 0. So that's the derivative. All right, so f prime of 1, is equal to 0. Well, what does that mean? Well, f of x has a horizontal tangent at x equal to 1 because f prime of 1 is exactly equal to 0. So that's how we know that there's a horizontal tangent there. We've proven that. And what you also notice is that as I go over there, you can see that the graph is going from decreasing over to increasing, right? We've got a minimum value. So start tying all those things together. Look at what you're saying and understand, okay, that's exactly what is being shown in our graph. So that's how you can find these values using a calculator. There are a couple different ways, but this is my favorite way. It really ties together the derivative with the graph itself. And now what I want to do is I want to take that and I want to look at a couple of like free response style questions, okay? So we already understand that the derivative is the slope of the tangent line, right? But when you think of slope, you want to think about rate of change. So another way you can think about the derivative is the rate at which a function is changing, like the rate that something is changing. And that comes in very useful when we're looking at these word problems, okay? So the number of people entering a concert can be modeled by the function that's given f of t. So t represents the number of hours after the gates are open. We want to find, all right, what are the values of f of 1 and f prime of 1/2. Sorry, f of 1/2 and f prime of 1/2. And then we want to do this using correct units. You're gonna notice that comes up a lot in calculus. It's like, can you really interpret what's actually happening here? And we want to be able to explain what each value represents in the context of the problem, okay? So the first thing that I'm gonna wanna do is say, okay, go back to my calculator and we're gonna add a new graph and we're gonna put in 560 times e to the sine of x. It says t, but we'll use x here, okay? Nothing pops up, but a dig graph is just outside of our range. And so we want to find f of 1/2. So if you just want to find the value, just hit trace, graph trace, and type in 1/2 or 0.5. And we want this, sorry, I'm covering it. We want that y value right there. So 904.482. So we can just write that down. That is to 3 decimal places, but if you can, go to 4. So as we do this, we're going to write this down that f of 1/2 is equal to 904.482. So what does this mean? Okay, so we're talking about people going to a concert. So at 1/2, hours. So at 1/2 hours, 904 people are doing something. What are they doing? They're entering a concert. So at 1/2 hours, 904 people are entering the concert. So that's exactly what happens. Like that details exactly what our value means, right? And since we're talking about people, you want to be very specific that yes, we got 904.482, but that's not just like, you can't have 0.482 of a person. So you do want to round that. Sometimes you can round it down, you can round it up to 904, 905. It doesn't really matter in this case, but just be clear that at 1/2 hours or at 30 minutes after opening, 904 people are entering the concert. So now let's find f prime of 1/2. Okay, we're going to do that again using our calculator, and we'll do it this exact same way. Analyze graph dy dx of 1/2 0.5, and we get 793.758. All right, so 793.758. All right, so what does this mean? So this is going to be at t equals 1/2 hours. The amount of people entering the concert. So we want to say two things. One, we're finding the derivative. Derivative means slope. Slope means rate of change. All right, so the rate of change, the rate we can increase or decreasing. So the amount of people entering the concert is increasing because it's positive at a rate, because it's the derivative of 793 people. And again, you can go to 794 if you want. But that's it. So at 1/2 hours, this is how you answer these calculus questions. All right, we've got part B here. So how many people have entered the concert 2 hours after the gates are open? Is it increasing or decreasing at this time? Okay, so to figure out 2 hours after, how many people have entered 2 hours after the gates are open, we want to understand that we really just want f of 2, because that means 2 hours after we know exactly how many people are in the concert. All right, so f of 2, we're going to come back. We're still using this, and we're going to go menu, right? We're going to go trace, we're going to graph trace, type in 2, hit enter, and we're going to get this y value that's right there, 1390.24, and that's what we're going to be using in our answer. So 1390.24. okay, so which means at t equals 2 hours, there are 1,390 people are entering. That's a lot of people in a concert. And so now we also want to say, okay, is that increasing or decreasing? So we really just want to find f prime of 2. We're really just going to be concerned about the sign. Is it positive or negative? So again, dy dx, be really comfortable with this, right? And put in 2, hit enter, negative 578.545. So that's going to be negative 578.545. So what does this mean? So at t equals 2 hours, like the rate is decreasing, right? So the rate of people, and this is where you want to use complete sentences kind of. So the rate of people entering the concert is decreasing because f prime of 2 is negative, it's less than 0. So that's how we know that the amount of people is decreasing. We even know the exact rate that is decreasing at a rate of negative 578 people. But that's not what it's asking. It just wants to know if it's increasing or decreasing and to justify our answer. Be very comfortable with this. Do these problems multiple times, because you will definitely get one of these on your free response section on the AP exam in May. Speaking of which, we've got one more problem, but this is going to be a little bit shorter, okay? So after being poured into a cup of coffee, so the coffee is going to cool, right? So it's really hot, you pour it into a cup, and it's going to start to cool. It's not going to be as hot. So there are mathematical formulas to determine how cool it's going to be. So then you can start drinking it, getting that sip of coffee right at that perfect opportunity, okay? So if we're using this function, T of t is 70 plus 110 e to the negative t halves. T is measured in minutes and T of t is measured in degrees Fahrenheit. So what is the temperature of the coffee 5 minutes after it was poured into the cup? Well, really all we need is T of 5, the temperature at 5 minutes, because T is measured in minutes, so we don't really need to do anything fancy around that. So T of 5, well, let's just get that, and that's all it's asking for, okay? Let's graph this, add a graph, and let's go 70 plus 110 times e to the power of negative x over 2. Again, I just use x because I'm not going to reprogram this for using t. But we want to find this, we want to trace the graph at 5 minutes. So we hit 5, enter, and we've got a value over there, 79.0293. All right, so we get 79.0293. Have we answered the question? Yes, but you do want to be a little bit more specific here, because although it doesn't say what are the units, sometimes it will, but even if it doesn't, write down the units, right? Our units in the last problem were people. We're talking about temperature and it's measured in degrees Fahrenheit. So I'm gonna write degrees Fahrenheit, and that's it. Now we want to see, is the temperature decreasing faster 1 minute after it is poured or 3 minutes after it is poured? We want to give a reason for that answer, okay? So we want to say decreasing faster, okay? So which one is more? 1 minute and 3 minutes. So we need to find T prime of 1, and don't write F prime, right? Because there is no F. We're talking about T. So we need to find T prime of 1, and we need to find T prime of 3. So we're going to find both of those things here. So let's do that. So let's go menu, analyze graph, and we're going to go 1. And we get negative 33.3592, write that down. And we're gonna go menu, analyze graph again, dy dx, and this time we're gonna go 3, and negative 12.2722, write that down. All right, so let's write both of those down. Our first one was negative 33.3592, and negative 12.2722. All right, so which one is decreasing faster? So look at both of these answers, right? And what you want to do is say, okay, they're both decreasing, but we want to know which one is decreasing faster. So think about in a race, right? Direction doesn't matter, right? Because if we're talking only about speed, we need to take out the directionality of positive versus negative, all right? So what is decreasing faster? Well, what is more negative? When we're looking at this, you want to be thinking about absolute values, okay? So we're going to say the temperature, so we're going to be using absolute values in our solution. So we're going to say the temperature is decreasing faster 1 minute after pouring, because the absolute value of T prime of 1 is greater than the absolute value of T prime of 3, right? Because then you get 33 versus 12. And that's how we know that is decreasing faster, or at least that's, I mean, we know it, right? We know it in our heads because one is more negative, but that's how you're gonna wanna write it, okay? And a lot of these free response questions is going to be like, how do you write these specific answers down? All right, so you're actually able to answer a lot of free response questions now. We've got a lot more practice to go, right? It's still just early in our calculus careers. So keep staying with it, but really practice these. These are so important. And now you're actually looking at practical use of using calculus every time you drink coffee in the morning. So hopefully that's what you're going to be thinking about tomorrow morning when you sip on that cup of coffee. All right. Of course, if you do need any help getting through this, if you do want to see that video on how to do this on something like a TI-84, please just comment down below. If you need any additional help, just reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.